All right, everybody, we are on Module 2, and we're doing the Paper Chromatography Lab. So here are the materials that you're going to need. So the very first thing you need to do is there is this bottle of 0.5 molar sucrose solution. You need to put that in the fridge because it needs to be really cold. And it needs to be in there for probably about 30 to 45 minutes. Then you need to get a handful of spinach leaves. I would get more than this. I'm just kind of limited right now. Plus my other half is up underneath a light. So I would say like 2 good handfuls of spinach leaves. Take half of those spinach leaves and put them underneath a light. I have mine sitting underneath a lamp right now. That's just to kind of get the chloroplasts to start performing photosynthesis for you. So just have kind of like the light shining on them for about an hour. And then the other leaves you can just kind of wait on. So this lab, the first part of it is just kind of getting everything prepared. So that's the first step, is making sure that you've got your sucrose solution cold and that half of your spinach leaves are sitting underneath a light for an hour, and then the other half you're going to do part 1 of the experiment. And then the light spinach leaves you're going to use in part 2. So the other materials you're going to need is 4 of your small beakers, your large graduated cylinder, a large beaker, chromatography paper, a stirring stick, 8 fresh pipettes, which you should have plenty of, even though you used some in the previous experiments. Some cheesecloth, some aluminum foil, a quarter, tape, cutting board with a knife, some water, 3 test tubes in the test tube rack, and then a whole slew of chemicals. So you need the acetone, the mineral oil, the acetic acid, the phosphate buffer, and then this fun bottle that is called DPIP. This we're going to have to put some water in it because it came as a powder to make it into a solution. So don't panic whenever it says in your instructions use a solution, because we're going to create that ourselves. All right. So the spinach leaves are going to have to come from the store. Obviously it's a perishable item, so it didn't come in the lab kit. So make sure you go out and get that. And we're going to go ahead and get started. So we've done, in our instructions we're on part 1, we've done step 1 and step 2, because you should have already put the spinach leaves in front of the light. And then we're going to go ahead and go through, and I'm going to mark everything, and then I'm going to come back to you when we're ready to officially begin. All right, everyone, so we're ready to begin with I've got everything labeled. So what it wants you to do is to start adding your solutions to your beakers. So we're going to add 10 milliliters of water to beaker 1. Then we're going to just kind of go through. I would do the mineral oil last, because you have to rinse out your graduated cylinder really well after you do each one, so that you don't cross-contaminate. So the mineral oil is kind of messy and hard to clean up after, so I would save that one for the last. So the first one we're going to do is we're just going to pour 10 milliliters of water into beaker 1. And you can use your large graduated cylinder or your small one. It doesn't matter. Okay. 10 milliliters of acetone into beaker 2. So They told me that this bottle was 10 milliliters of acetone, and it is only 5.5. So that'll be fun. It should still work. But yeah, sometimes these kits, you know, they don't come fully stocked. I've had problems with that in the past, so if you have issues with that, contact the company as soon as possible. Alright, so there's the acetone. Mineral oil, I'm going to skip that one and I'm going to go to acetic acid. Okay. So this had water in it, so I don't need to rinse it back out for the acetic acid. Alright, so my acetic acid came with a squeeze bottle. So that's going to take forever. So I'm going to go ahead and pause the video, and whenever I come back, I'll have this ready and the mineral oil ready. Okay, so I'm back, and I've got my 10 milliliters of each solution into each beaker. So my mineral oil is in the third beaker and my acetic acid is in the fourth. And the directions ask you to cover it with aluminum foil. So you're going to have to cut or tear the aluminum foil to cover the beakers. Aluminum foil tears pretty easy, so whoa, almost had an accident there. Okay. You just want to make sure that it's sealed really well. And that also you can still see what number beaker you're working with. And you can see it. You don't need too much. So some of this stuff you'll have extras of. Okay. So now that we have them sealed, we're going to move to the next step, which is where you need your chromatography paper and unfold it. And then it wants you to draw a line approximately 1 centimeter from the bottom. I want you to draw a little further up than that, not by much, probably 2 centimeters, because we've had issues in the past where the pigment line ended up being, so that's, the pigment line was too far down and it got soaked in the beaker, and then the experiment didn't work. So I'm going to draw a little line right where 1.5 centimeters is from the bottom. 2 looks a little too high. So I have that mark, and then what I'm going to do is I'm just going to draw a really light line. Okay everyone, so my camera went off in the middle of me doing something, and I was recording without it actually recording, so I'm redoing this part. So your chromatography paper, in the directions it tells you to go 1 centimeter above the bottom, and I want you to go 1.5 centimeters from the bottom. And we're just going to take that and we're going to mark it, and then take your ruler and then just draw like a just really light straight line with your pencil all the way across. So you should end up with a line that's going all the way across, which is 1.5 centimeters up to the top. Now this is the part where my camera stopped recording, so I'm just redoing it. So that you can see it. So you take a spinach leaf and you place it on the pencil mark that you just drew, and you take your quarter and you just kind of push down on the leaf to get the pigment to come onto the line that you did. It's okay if it goes a little bit above the line or below the line. It doesn't have to be perfect. And you just want to get that pigment of the spinach, that green pigment, all the way across the line until you've put pigment across the entire line. I already did that and I thought the camera was recording, but it wasn't. So once you get your pigment all the way across, you just take your paper and you cut it into strips. And you're just gonna need 4, one for each beaker. So what you're gonna do is you're gonna take some tape and you're gonna roll the tape to where you can attach it to the back of the chromatography paper. And you don't really need it to be this tall, but I just left it. Okay, so the first one that you're gonna do is the water. And what you want to make sure is that the pigment does not touch the liquid. It does not touch the water. Only the bottom part touches the liquid for each solvent. And so what's going to happen is that I put it in here and then I take my tape and I tape it. Oh no. So, yep, I messed it up. So see, that happens. So I'm just going to put that one to the side and get another one. So I'm just going to take it and I'm just going to touch it to the water and then tape it to the side. And so what's going to happen, and so you got to be real gentle with it because that's how I messed it up the first time, is that the solvent is going to travel up the chromatography paper and it's going to attach to that pigment, and the pigment's either going to migrate or it's not going to migrate. It just depends on the type of solvent you're using. And so you just let it sit there for about 2 or 3 minutes until the solvent is no longer, the liquid's no longer rising on the chromatography paper. And then you're going to take it out and you're going to mark really quickly the solvent front, which is where the water ended, or the liquid ended, because it won't always be water. So I'm gonna, if you're a little nervous, because see, my tape is just acting ridiculous. If you're a little nervous about it, you can just hold it so that it doesn't fall into the water, because you have a limited amount of pigment and you have a limited amount of tape. So it's hard to see in the camera, but you can, it's, in real life, you can actually see the liquid traveling up the chromatography paper. So it's been sitting in here for a little while. I'm going to go ahead and take it out. And right there is where the liquid stopped. So I'm going to put this on a piece of paper, or sorry, on a paper towel. And I'm going to take my pencil and I'm going to mark that line. I'm going to make a line on it because that's where my liquid stopped. And that's important because you have a equation that you have to use to see, it's called the RF factor. And in your combined lab report, or no, in your instructions, it gives you that equation right here. So the distance the pigment migrated. Well, in this one, the pigment didn't go anywhere. There's no bands. So we say 0 for that. And then the distance the solvent migrated is from the bottom of the chromatography paper to that line, that solvent line that you marked, which for me was about 4 centimeters. Now, if you're if your pigment didn't go anywhere, your RF factor is automatically going to be 0 because 0 divided by any number is 0. So when you do your lab and filling out your data table, then the RF factor is going to be 0 for that solvent, which was the water. And so you're just going to repeat this same process with each different solvent. I'm not going to run through all of them because it's the same exact process. So I'll take my next chromatography paper, and I'll put it in beaker 2 and watch the pigment migrate and do the solvent front, and then do all my calculations. So just in case you need to see what pigment migration looks like, you can see that right here is where the pigment originally was, and then I dipped it in a solution. I'm not gonna tell you which one because that'll ruin it for you. And then you can see that the pigment traveled all the way up to here. So that's what it looks like whenever the pigment travels. So there's no pigment left at the original line. And so for this one, what I would do to calculate the RH factor is that I would measure the distance the pigment migrated from the pencil line to wherever it stopped. And so that would be my my top number in that equation, and then the bottom number would be the distance the solvent traveled. So from the bottom of the chromatography paper to wherever it stopped, and that would be my bottom number. And then you just divide those numbers and you get the RF factor for that solution. Hey everyone, so we're on part 2 of the chromatography lab, and I just wanted to show you what you needed to start doing before you can actually get into like the meat part of the lab. So you need to take a handful of spinach, and it needs to be a lot, like a really good handful, and go ahead and put it underneath a warm light. I know in the lab it says sunlight, but you really need to get an incandescent, not an LED, an incandescent bulb, and have the spinach leaves sit under that light for at least an hour. Don't leave it longer than an hour because then it causes the spinach to wilt. So just leave it like this for an hour, and then you'll be able to do the next part of your lab. While this is happening, you're going to want to put your sucrose solution into the refrigerator and let that sit in it for an hour so it can be cold. Alright, so we're now going to be doing part 2 of the chromatography lab. And earlier I showed you how to mix the DPIP. And we're going to go ahead and do the second part where you have to chop up the spinach and put it in the sucrose solution. So go ahead and get your sucrose solution. You're going to need your phosphate buffer and your DPIP, and then some water. Okay, so now that I have everything, you're going to want to take the spinach that you left under the light for an hour, and remember the light was supposed to be warm. It was an incandescent bulb. Now if you had like a really hot sunny day, you could have done it outside, but right now when I'm doing this, it's cold outside, so I can't do that. So that's why we just went ahead and used the lamp. So be really careful, and you just want to chop so that way you can kind of get the chloroplasts released from the spinach, because we want those to go into the solution, and so it's just kind of like chopping for a salad. All right, so we're gonna take a handful of that, and we're gonna put it into a Ziploc bag. Okay, and you don't have to put all of it in there. You can just enough. You definitely want a large quantity. And then we're going to pour the entire bottle of sucrose solution, now it should be cold, into the bag. Okay. And then make sure you get all the air out of the bag, because now you're going to be mashing it, and mash it really good, because you want to get the, like I said, you want to get the chloroplast into the sucrose solution. So when you're done, you want this solution to be green. I actually did this earlier and I didn't use enough spinach leaves, and so I had to redo it. But I actually had to make the sucrose solution, since I used it all in the first one, I had to use the sucrose, I had to make the sucrose solution, and that was fun with lots of calculations. I haven't had to do those chemistry calculations in quite some time, so but it all worked out, and now you get to learn from my mistake. And it's quite unfortunate that the lab kit does not come with multiples of everything, because if a student makes a mistake, then you kind of can't, you can't redo the lab, you don't have enough materials. So okay, so my solution is now nice and green, and like I said, you're just gonna like you're just rubbing it, like you're just mashing it. Okay, and this is this should be done by now. Okay, so now what you're gonna do is you're gonna take your beaker with the cheesecloth, and you're definitely going to want something to hold the cheesecloth over the beaker, because now we're going to be straining the liquid. All we want is the liquid. We don't want pieces of spinach in there. This might get a little messy, so I'm going to go ahead and put my paper towel under it. Okay. Now it says to push the cheesecloth into the beaker a little bit, so that's what I'm gonna do. I put it on there, and then it's light enough to where you can push it down. All right. So now we're just gonna filter it. I'm gonna open it up, and I'm just gonna start pouring. And so what should happen is you should end up with just liquid and not any kind of chunks into the solution. Yep, that's catching it real good. So you don't have to like triple layer the cheesecloth or anything. I just did a single layer and it's working out just fine. Okay. I'm just squeezing it to get any kind of liquid out. All right, and so that's what you should end up with, is a really dark solution. And so that contains the chloroplast and parts of the plant. So now we're gonna move on to the next part. I've already labeled my test tubes 1, 2, and 3. And so now we're just gonna go through, and you need to have 3 pipettes for this. Now I showed you this earlier, but on your pipette there are markings, and your pipette actually goes up all the way to 3 milliliters. So what we're gonna do is they want you to put 3 milliliters of water into each test tube. So I'm probably not going to be able to get up all the way to 3, but I did get up to 2, so I'm just going to say 2, and then 1. 2, 1, 2, and then 1. And then I'm going to set that aside because I don't want to cross-contaminate. And then I'm going to add my phosphate buffer. And so we're just going to kind of unscrew the cap. And then the bottle comes with the little squeeze tip. You can remove that in order to get your pipette in there. Just be careful when you do it because it can be in there pretty tight. All right, so new pipette. And we're gonna put 1, 1, and 1 in there. And now my daughter needs me, so I will come right back. Okay, so now that I've helped my daughter out, we're in the middle of the COVID pandemic, and she's doing her homeschool work, which I'm sure some of you have been in the exact same situation. Okay, so now we've done our water, we've done our phosphate, and now we're going to do our DPIP. Now the DPIP, I already showed you how to turn it into a solution, because when it comes in your lab kit, it's powder, and you need to pour 50 milliliters of water in it and then just kind of shake it around and you should be good. So now using a new pipette, we are going to put 0.5, which you're going to have to it's 0.5 is at the very, very bottom of your pipette. It's kind of hard to see, so you're going to have to be really careful whenever you do this to make sure. And it's a really dark blue liquid. All right, we're just gonna put 0.5 into each test tube. Okay. All right, so now we are ready for our sucrose and chloroplast solution that you made. So I'm just going to go ahead and take the cheesecloth off the solution. All right. And so we're going to get the stirring stick, and we're just going to stir it up a little bit just to make sure everything is in suspension. And now we're going to take a brand new pipette, and we are going to add 2 milliliters of this solution to test tubes 2 and test tube 3. You're going to leave one alone to act as a control. So we're going to go ahead and soak up, oh, my measurements are on the wrong side. And I can't quite get to the 2. So I'm just going to do 1. Okay, rechecking my work here. All right, so that's 1 milliliter, and now 2. 1 milliliter, and now 2. Okay, so now they want you to cover the second test tube with foil, and you want to cover it completely. So you're going to take your aluminum foil. You're not going to use the whole thing because that's going to be too thick. So I'm just unwrapping it. I'm going to tear it down the middle. And I'm going to take test tube 2, and I'm going to wrap it so so that it's completely covered. You want the top covered as well, so it shouldn't be open to the air. I didn't quite get enough for the top, but you want to squish it down so that way you can put it back into the test tube rack. And it's not going to go all the way in there, so just push, but don't force it, because I don't want you to break the glass into your hand, because that is a horrible injury to have. All right, so I'm just going to take a little bit more and just cover the top. Okay. So now what you're going to do is you're going to take your test tube rack back over to your lamp that has the incandescent bulb, and you're going to have it shine on this for at least 3 to 8 hours. And what you're looking for is you're looking for a color change in the DPIP. So you'll be able to see at the bottom the colors, and you're looking for it to turn from blue to clear. And how long does that take to turn from blue to clear? So you're going to need to be around for at least 8 hours. So don't like leave this and go to the store or go out clubbing or whatever you do for 8 hours and then come back, because it could change at like the 4th hour or the 5th hour, and that's important information to know. So I'm going to take it over to my my lamp, and then I'm going to show you what it looks like when you set it up, because you're also going to need to put water in front of it to kind of filter the light. Okay, so here is my last setup. So here's my lamp with my incandescent bulb in it, so that way it'll get warm and a lot of light. Like I said, LED bulbs do not work. You need incandescent. Or a really bright sunny day, like where it's 85 or above outside and there's no clouds, which is that only happens in summertime in Colorado. Okay, and so then I put a beaker full of water in front of it. That just kind of helps to filter the light, and so you'll want to check on this starting at the 3-hour mark, probably every hour, to see if that changes from that dark blue to the clear. So the one that's covered is kind of representing the dark reactions of photosynthesis, and the number 3 test tube that's on the far right is representing the light reactions, and then the test tube number 1, you guessed it, that's probably most likely your control, because we didn't put any chloroplast solution in that, so that's what you're comparing it to.